In the previous tutorials, we have set up a bank project with different clusters, and also it might be best to illustrate this by going to what we have got so far in the file system. So we have the bank, we have to store the business logic, we have the docs to store the informal documentation, and we have the root cluster to store the main class for execution, and we have the tests for storing the test cases. And we have actually developed some code that's just enough for setting up our infrastructure and to run some test cases. And this is indeed the essence of test-driven development. You always want to write the test cases as soon as possible. And also we have illustrated the essence of design by contracts. If you look into the account class, remember in the previous tutorial, we actually started to develop our attributes and develop the contracts of the features. So first of all, we define the invariants, which constrains the combinations of the possible combinations of the attribute values to make sure the relationship between the balance and credits is respected according to our informal requirements, which is documented here and also in the class header of the account class. So always remember, professional documentation should be part of your design practice. It is simply not acceptable to be ignored. Okay, and for the particular feature in our account class, we also define the post condition, and all of the contracts are actually completed even before the body implementation of make was created. So this is really the essence of design by contracts. You want to somehow to have the contracts drive your design, and you also want to have the tests to drive your developments. So contracts and tests. So these are the most important aspects of this course. So you want to make sure you really put this into the practice of your software development, and you can benefit a lot from there when you're developing large projects. Okay, and also in the previous tutorials, we also show you how you can combine mini test cases into a single test case, provided that you actually use the correct mechanism to make sure in the intermediate results for mini test cases are not ignored. Let me remind you what we have done. So if you go to the test account class, you can see that we actually have two mini test cases to actually check the manipulation of two account objects, ACK and ACK2. The first mini test case and the second mini test case, both of them are actually the results for both of them are actually wrapped into a check in code check assertion to make sure if any one of them actually failed, it will be brought up as a contract violation, specifically the assertion violation. And also we show you how you can have also other forms of contract violation. For example, you might have the precondition violation to say it would be the obligation of the current client, which is the test account class, to make sure right before you call the feature make on this account object, you are supposed to satisfy the make's precondition. In this case, because make is actually a constructor, so there's no precondition to be satisfied. But later on, we are actually going to see, for example, if you want to call withdraw on this account object, then the current class, which is test account, has to make sure right before we call the withdraw, we have to make sure the current credits for account is sufficient for the proposed amount to be withdrawn. And another form of contract violation is after the feature call has terminated, and it has to establish both the post condition and the class invariants. And those two establishments are the benefits of the current clients, because we as a client, we want to make sure when we call the feature and upon its termination, the service providers should really give us certain guarantee that will meet our expectation. And on the other hand, these benefits are the obligations of the supplier, which is the account class. So you really have to make sure you're clear about who the client is and who the supplier is, depending on who's calling the feature and who is supplying the development of the feature. Okay, and we also show you that in the test-driven development, you always want to get a green bar from the test report that's generated by the ES testing library. Again, eSpec testing library. And again, eSpec stands for IFO specification. You always have to make sure when you first created your brand new projects, you have to add the eSpec testing library into your projects. And always you have to make sure whenever you introduce any new changes into your projects, you have to rerun all the test cases. And to make sure if you do have a red bar, then that means the latest changes you have introduced have actually introduced some new bugs into your software. So you gotta stop with your current developments and fix them first before you proceed further until you actually see a green bar. Yeah. Okay, that's basically what we have covered in the previous tutorials. What's left is we haven't really shown you if you do see a red bar in your generated test report, then what should you do in order to actually fix your code? Apparently, the most obvious way to fix your code is you can try to review by doing some manual inspection, eye inspection of your code and see, yeah, this part might be wrong and that part might be wrong. But that's not really the most efficient way to do it. If you have some complicated project where you have so many classes and their interactions with each other is so sophisticated, you simply just cannot do review or by just guessing where the box might be. So in this tutorial, I'm going to show you that you should really first to see which test cases fail and go to the first one that failed and put the appropriate breakpoints to actually stop the execution there and examine the snapshot of the state space to see if the state space really matches what you expect. If it does, you should really just go kind of have a slow motion version of the execution and try to go one step at a time until you actually can spot the problem. Okay, that's sort of the preview of this short tutorial for this tutorial video. Again, let's just go to our projects, and again, as always, we have to make sure that we are in the right location for the workspace, and make sure you launch the correct version of the IFO Studio for the current semester. So now it's summer 2015 and the correct version is 1501 for IFO Studio. And make sure you put an ampersand to run the process in the background. And now, again, we're going to choose the existing projects for the bank projects. And always make sure the location has been selected properly. And now let's open that project. And so let's go directly to the test account. So let's just make sure currently all the test cases run with a green bar. To run the test cases, you cannot just go, you do not just go directly say run. You actually go for the, there's a down arrow to the right of the run button, and then click on that. You get a drop down menu. Go to the option of run workbench system and run it. So currently we do get a green bar. So let's say now we deliberately introduce an error into the code. Let's say you are the supplier of the service of account, okay? And currently we only have one feature implemented, which has the post condition here. and it has the invariance here. So the body implementation of this make feature here is supposed to establish two things. It is supposed to establish the post condition, which documents what this feature is intended to achieve, and also to establish the invariance, which somehow reflects the business rules or the requirements in terms of the data integrity status. As you can see, one of the invariants is saying that the balance and credits should really be related to each other in the expected way. Okay, so now let's say somehow when we were developing the code, we actually did the implementation wrong. So this is actually the same mistake as before in the previous tutorial, but in this case, I want to show you how we can actually spot that, and then how to use the debugger and breakpoints to identify that, examine the unintended state space, unintended states, and how we can fix the code using the debugger. Okay, so let's introduce this bug intentionally, and let's see how we can capture that. So apparently, this wrong implementation will violate the correct post condition. So this is a proposition that must be satisfied by this line. Apparently it is not. That's why we will actually get a red bar from the test case. Okay, let's just review very quickly of the test case we have written in the previous tutorial. So here, always remember for the Boolean test query or for other kinds of test query, other test feature which we'll introduce in later tutorials, always put a comment feature that is inherited from the ES_test testing class with a colon as the delimiter. To the left, you put the identification number for your test case. To the right, you actually put a short summary of what the test case is intended to test. And these two pieces of information will be reflected in the generated test report. Okay, so now because now we have a wrong implementation for the make feature, so we should expect a post condition violation for the test case. And remember again, so there are three, in the previous tutorial, we mentioned that there are several possible ways to fail the test case. Number one, if there is no contract violation that occurs throughout the over the course of the body implementation execution, then if the final result value is actually false, then you will actually get a failure. You will get a failure for the test case. Number two, if any of the mini test cases that you actually try to run as part of the entire test case, if they fail, you will actually get the check assertion error. That's number two. Number three, if the precondition of the feature that you're trying to call is violated when you actually call that feature, it is your obligation as the clients to make sure it actually it is actually satisfied. So that's the third possibility for test failure. And the fourth possibility is upon the termination of the feature execution, if the post condition is not satisfied by the code, which is secret, that is provided by the supplier of the feature. In this case, it is the account class that supplies the code for the feature make. And in this case, we get a post condition violation. So always remember, and another possibility is if the post condition actually does not establish the invariance of the class, then you will also get some violation. Because in the previous tutorial, we already have seen post condition violation, why don't we actually make it a little bit more fun by, let me see if I can do that. What we can do is, actually at the moment, maybe, okay, let's not worry about that. This may not be a suitable place to do. Let's just keep the original post condition violation. I promise I will show you some invariance violation in later tutorial. Okay, so we keep this wrong implementation here, and then we go back to the test account feature, and now because the implementation is wrong and it is not going to establish the post condition, so right after this line of execution, we should expect a post condition violation. So let's first recompile the code, rerun the workbench system, and we do see a red bar. Okay, now it comes for the main meat for this tutorial. Let's say you are seeing this test report and you see a red bar. So how should you proceed with debugging your software by using the tool that's available in the iFruit Studio? So there are two things you can use. The one thing is to set a breakpoint for you to stop at some point of the execution path to examine the snapshots of the state space. And the second thing you can use is to use the debugger mode, the debugger view, to actually see how expressions are evaluated in a particular snapshot so that you can actually compare the values there against your own expectation. If they don't actually match, that means there's something wrong with your implementation. That's where you can actually see how you should fix the code. When you are actually doing a big project, the use of the breakpoints and debugger explorer is extremely useful to help you to save time. But for a small project, of course, you can simply do some manual inspection. But for the medium size or larger size projects, you definitely have to use the breakpoints and debugger explorer to help you. Okay, let's just make it simple for the illustration. Let's say, because imagine that we have 100 test cases in the test report, and this guy here is the first one that failed. And now it failed for the reason of post-condition violation. Okay, so the best way to do this is first, we just run the system no matter what, and let it stop at the post-condition that got violated. Okay, so let's do run. Okay, now it stops at a point where this post condition was violated. That's why it stops there. So you can see the green arrow here stops there. So this is the execution has not been finished, but it was simply paused because the post condition violation. And the way to see why the post condition was violated is to have a look at this proposition here. So we say at this point, after initializing, let me scroll. Yeah. So this is the make feature in the account class we are talking about. So this post condition here is saying after initializing the account objects, its credit value must be equal to the A credits, which is the argument value. Let's examine the states at the point that this proposition is not satisfied. So if you move your mouse around the credits, so this shows you the current value for credits, which is 9. And this is the value that we pass, which is 10. The reason that we are seeing 10 over here for a credits, you can see also here, it's the argument value. So if you look at the cost stack over here, so we are currently in the make feature of the account class. So you can see over here, feature and class. And the previous one in the cost stack is where this make feature got called. So here, the make account, let me expand this a little bit. So let me see. Okay, so you can see that the previous one is the test account creation feature that's in the test account class. So this is the caller context for this make feature. And you can see that over there we are passing the value 10 to the make feature. It is why at this point we actually see 10 as the A credits. You have to convince yourself why this is the case. Okay, and as we can see, 9 is certainly not equal to 10. So that's why we get a post condition violation. Alternatively, so you can actually see it's a much more detailed view over here. So this objects panel shows you a snapshot of this particular class context. Because now we are in the context of account, So it is going to show us, let me just bring you back to the previous one a little bit. So you can see that in the test account creation, in the test account creation feature here in the test account class, we are trying to make this feature call. So we are trying to call the feature make on this account object called ACC. So now when we go to the context of the make, so now we are in the context of the objects ACK. So when we talk about the current objects here, so the current object here really refers to the object ACK here. Again, you have to convince yourself to make sure you really understand why this is the case. And this is really the essence of understanding the debugger view. Okay, so ACC here, object here, is the current objects here. And the current objects up to this point, after the initialization, has the balance of 0. And you can see 0 is the balance, and 0 equals 0 is okay for the first post condition. However, for the credits, it's actually 9, which is not equal to A credits. You can also see the A credits is under the arguments bookmark for this particular feature. Okay, and you can see that, so this is how we actually can observe the state of the system at this point of failure. Okay, but now this actually, let's say we only see that there is such a post condition violation, but we only reach this point when we only reach this point after the whole implementation body has been executed. This is not very useful to us, actually. It is useful in the sense that we can see which post condition has been violated. However, to really see what's going on wrong with the implementation, we really have to somehow to stop. We somehow have to move to let the green arrow stop in the very beginning of the code implementation body. The way to do that is to put a breakpoint. Okay, so there are two ways to put a breakpoint. So one way is to say, okay, because we see this is a post condition that's being violated, and we want the next time the green arrow to be stopped here. So we can simply, you can see the circle here. We can say next time, let's stop here instead. So now I'm now putting a breakpoint over here myself. So next time, instead of actually executing here this implementation body without pausing, it's going to pause in the very beginning, and then I can actually go step by step, and then examine the objects view to see how the snapshots of the state space change from one to another to actually compare against my expectation. So this is one way to put a breakpoint. Let me show you another way to do it. So this certainly will work. Let me show you another way. Another way to do it is to say, now I identify that make feature is really is where the post condition violation occurs. So maybe I should really go there and put a breakpoint. Okay, let me stop the current execution there by clicking on the red square here. To put a breakpoint, remember in the previous tutorial I show you that to show your clients, you actually let me just go to the account class first. Okay, let me close the other two just to avoid confusion. So in the previous tutorial, I mentioned that to show your clients your design, you have to give them the contract view, which shows only the contracts while hiding the implementation. But now, you as the developer, you want to put a breakpoint for your implementation. In this case, you want to go to the flat view. If you go there, first of all, you can see the circles exactly like what we saw a few seconds ago. So this is where you can put a breakpoint. So briefly speaking, so a flat view accumulates all the codes that the current class inherits from all its parent classes. That's why usually in the flat view, the class is in a much larger size, because sometimes when you are trying to debug, the feature that's problematic may not be in the current class. It might be the feature that occurs in the parent class. because yeah, in the parent class, in which case you want to really put a feature there, put a breakpoint there. That's why sometimes the flat view is actually better to put a breakpoint. Okay, so now we are in the flat view, and instead of actually just manually try to scroll down to where we should put a breakpoint, because we know the problem is in the account class we want to put a breakpoint around the make. So we actually enter the make over here in the feature search box and press enter. So now we are in the make, and we want to put a breakpoint right in the beginning of the code implementation body. So that means right before this line of assignments is executed, we're going to pause it and see what's going to happen. So we can actually observe the states before this line was executed and also after this line was executed. Okay, so we're going to see how we can do that. And let's run the debugger. To run the debugger with as opposed to run the workbench system, what we're going to do is to say run. So this will cause the runtime engine to pause at any breakpoints that you set for your system. In this case, this is the first breakpoint you will encounter. So let's click on run. And let's see what happened. So you can see, compared with what we saw before, when we didn't put any breakpoint, the green arrow would be paused here, and here, and that's where the post condition violation occurred. But now it actually paused here. So this is where we put a breakpoint. So now this is the point right before this line of assignments was executed. Okay, so let's see what's the state space. Let's examine that. So again, in the objects view, and the current objects here refers to, because now we are in the context of the account class and the make feature of that. And this is called by, if you look at the stack, this is top of the stack. Just go to the next one that's lower than that. So this is the client side for the make feature. Okay, this is where we make the feature call to the account objects. So we are making this feature call on the account object ACK. And this ACK over here is indeed the same objects here. Let's verify that to really convince you. Okay, now let's see. So here we can see that the current objects here is now test account, right? And we can see that under the local variables, at the moment, actually we cannot see, sorry. At the moment, you can see, first of all, it is void. Why they are void? Because you can see that here the arrow stops at here, so that means this is at the point right before we try to initialize the objects, right? And this objects has not been initialized just yet, so that's why it is void. But once we step further after this line, beyond this line, we actually get the ACC becomes something that's non-void, right? Okay, so now what you have to bear in mind is this ACK object here corresponds to the current object here. Okay, so now let's examine the states, because we were trying to make the make feature call with 10 as the argument value. So that's why the credits here is actually 10 from the arguments bookmark. So you can see right before this assignment takes place, balance equals 0. The reason that it equals 0 is because balance was declared as an integer. An integer always has the default value as 0. And now we are trying to initialize that to some value that just happens to be the same as the default value. So don't get too confused. So, however, let's say if balance is something that's not really of some primitive type like integers or something, it would be void as by default. And if you initialize that to something, it will be something different. Okay, but in this case, they happen to be the same. Okay, so now this is right before, And now, what should we expect to see after? In this case, it's actually straightforward because balance at this point is 0 by default. And it is now reassigned to be something that happens to be the same. So so here we can actually choose to, as you can see, there are 3 icons here. So for now, you only have to worry about the first one and the second one. The first one here is called execution one step at a time. And the second one is to step into a routine. So the first one means if we click on the first one, it's going to execute this line of code without going into any further feature call. But in this case, we actually don't have any feature call, so that's okay. I'm actually going to show you a use case for the step into after the current debugging session. Okay, so if we say one step at a time, so if we click on that, we should expect the green arrow to move from here to here. Okay, so once it moves to here, that would be immediately after this line of assignments execution. Okay, let's go one step at a time. So now you can see the balance remains 0, which is okay. So now, this is the critical bit. So now we have credits, and we're actually going to assign that to something here. And you can see at the moment, credits is 0. And it is going to be assigned to be some expression here, a credits -1. So we are actually going to observe when we say execution one step at a time. Oh, by the way, in this case, in the case of the current context, we cannot really go say one step into a routine simply because the assignments instruction is a basic operation. There's really no way for you to go into it to see how the assignment has been completed. But I'm going to show you the step into a routine will be useful in some context. I'll show you in, just after this debugging session. I'll start a new one. Okay, so now let's see. So now right before we assign the credits into something that's wrong, let's see how the value of the credits would change. So currently credit is 0, and let's click on execution one step at a time. If we do that, you can see now it's being highlighted as red. So it goes from 0 to 9. So now we can see this is where the problem is. We in the post condition, we expect the credits to be equal to a credits, which is 10. However, in the implementation body, this evaluation here evaluates to 9, right? And this is another way to see it. So let me show you one thing which you really have to also try out yourself. So over here you can see the breakpoint panel, and over there there's something called watch. So, and over there you can actually put some expression and evaluate. So this is a very handy place for you to say, at this point of execution, I would like to know, based on the current state, what would be the value of certain expression. Okay, so in this case, I can see that because credits is going to be assigned to this expression here. So I would like to know what's really the value of that. Okay, so over here, I can click on expression here. I can say a credits -1. And you can see that it's a very handy feature. You really have to master yourself on using this feature. It's extremely useful. You actually see when you actually get a more complicated code, this is very useful to do, to use. So now you can see that this expression here evaluates to 9. And this expression value, which is 9, is assigned to credits. And the expression value here, you can see credits, that's also valid expression here. What I meant to say is, yeah, exactly. Okay, what I want to say is, over here, we are actually going to see some contract violation. So let me see. A credits. That's what I meant to type. Okay. So now you can see this is the arguments. This is the argument. This is the current value for credits. And the reason that the current value for credits becomes 9 is because it was assigned to this expression, which is also 9. So you should really play around with the watch panel to actually, so you really have to just switch to the watch tab over here on the red panel here to make sure you can really use it. Okay, so now we can see that by using the debugger, we can actually examine exactly what has happened to have a slow motion version of the execution and see what has gone wrong. Okay, so let me just remove the breakpoint because I would like to show you one more thing in another debugger session. Okay, so now let me put a breakpoint in a different place. We used to put a breakpoint in the account class. Okay, but let's say now I only know that my test account actually failed, and I know which test feature actually failed because I can see that from the test report, right? So now I want to say I would like to stop in the beginning, okay, in the test account creation. So don't get confused. Previously, we tried to put a breakpoint in the account class, and now we are trying to put a breakpoint in the test account class. The reason I'm doing this is because I would like to show you how you can use the step into a routine feature to show you how useful it can be. Okay, so now let's run again. So this is a brand new debugger session. Okay, so now the green arrow here pause at the beginning of the test account creation, which is exactly how we corresponds to how we selected the latest breakpoint. So now we have the option of step into how the comments actually works, which is not very exciting because we know it's only for documentation purpose. So we would like to just go from here to here by clicking on execution one step at a time. So let's do that. Okay, so now we would like to see, because now we are on the client side of the make feature. Remember, we are now in the test account class, so now we are on the client side. We would like to know what really happened in the supplier side. However, if we simply just do to say execute one step at a time, we are actually going to skip that supplier's secret. We're going to skip that and go directly to here, which is not what we really intend to do. We would like to go into the secrets to see what exactly happened. So here, what we are going to do is to say step into a routine. And the routine that we are talking about here is the make. So at this point, we would like to go into the make, right? So if we do that, you can see that once we say step into a routine, instead of going to here, we are actually going to switch the context from test account into account. Okay, let's watch the difference. So now let's say step into a routine. So now we are now in the context of the make feature of the account class, and everything else would be the same as the previous debugger session. So now you can see just by setting the breakpoint in different places will actually affect the way you actually want to walk through the state space from one snapshot to the other. So you really have to play with this small example to really get a feeling of how these two buttons actually work, and how they actually work together with the watch expression here. So you really have to play with that yourself. But I believe this tutorial must give you enough information to proceed with more complicated example. Okay, so let me stop this debugger session. And as a very quick recap, so up to now we have done the demonstration using a bank project example to illustrate to you the use of the exercise of test-driven developments and design by contracts. And the essence of test-driven developments is you always want to write the test cases as the earliest possible time to make sure as you develop your software one small bit at a time, every time after you have developed some small part of your software that can be testable, you should test that immediately. And if all your previous tests actually still pass, then you can go ahead and develop something new. If any of the previous test cases actually failed, that means you have introduced some new error or new bug into your software, in which case you really have to fix them by using the breakpoints and debugging mechanism I have just shown, and make sure you can fix the bugs and rerun all the test cases so you can see how this iterative process works. Once until you actually get a green bar, and then you can proceed with your developments. Remember, test-driven developments and design by contracts. Always write test cases as soon as possible, and also try to write the contracts to document what you intend to achieve before you actually go ahead to write the code that actually specifies how, in a step-by-step manner, you're going to achieve the specification. Okay, so in later tutorial videos in this series, we're going to see how we can expand the business logic with some other to actually cover more of the business logic. If I may remind you about it, if we go to the documentation of the bank requirements, so far we have only covered R1 basically, but we are going to see how we can define some deposit and withdrawal features and do other things that will also require some new classes. That will be the focus for later tutorial videos, so stay watching.